Hi friends, in the previous video we have discussed a problem based on correction of basic runway length. So in this video we are continuing with the same topic and with another problem of different type. Okay, so the question is, the basic runway length is 1600 meters, airport elevation is 125 meters and airport reference temperature is 25 degrees Celsius. Calculate corrected basic runway length. In this question, the chainage and gradient are given. Okay, chainage is 0 to 300. The corresponding gradient is plus 1%. 300 to 900, it is gradient is minus 0.2. 300 to 1500, the corresponding gradient is plus 0.5. 1500 to 1800 plus 1. 1800 to 2100, the corresponding gradient is minus 0.30. So in the question, basic runway length, the given data are basic runway length, that is 1600 meters, elevation 125 meters, ART, that is airport reference temperature, it is given as 25 degrees Celsius. So to solve this type of problem, there are 3 steps. That is, we have to do 3 corrections. First correction is correction for elevation. Second one is correction for temperature. And third one is correction for gradient. In this question, the effective gradient is not given. That's why we have to find the effective gradient first. Okay. So coming to the first step, that is correction for elevation. So the correction is, in the previous video we have discussed how to do the corrections. Okay, once again I am repeating that. Correction for correction of elevation, we have to increase at the rate of 7% per 300 meters. Okay, this value we have to remember. And correction is basic runway length, that is 1600 into 7%, 7 by 100 into elevation, that is 125 divided by 300. Okay, so the correction will be 46.67 meters. And the corrected length is equal to the summation of basic runway length, that is 1600, and this correction 46.67, which is equal to 1646.67 meters. The second correction is correction for temperature. We have to find the standard atmospheric temperature. Okay, at 125 degree elevation, which is equal to 15 minus 0.0065 into that elevation, that is 125, which is equal to 14.19 degrees Celsius. And the airport reference temperature is given in the question as 25 degrees Celsius. Okay, so the rise in temperature is the difference between airport reference temperature and standard atmospheric temperature at 125 elevation, which is equal to 25 minus 14.19, which is equal to 10.81 degrees Celsius. And the correction is that corrected length, that is this one. 1646.67 into 1%, 1 by 100 into that rise in temperature, 10.81. So correction is equal to 178.05 meters. And the corrected length is the summation of that corrected length, that is 1646.67 plus that correction, that is 178.05, which is equal to 1824.72 meters. And after doing 2 corrections, we have to do a check, that is ICAO check. According to that check, the total length after correction should be less than 35%. Okay, so the total correction is equal to 1824.272 minus 1600 divided by 1600 into 100. Okay, so it will be 14.04 degree, which is less than 35 degree. 35%. So it is okay. So the third one is correction for gradient. Here in the question, the effective gradient is not given. The chainage and corresponding gradients are given. Okay, then we have to determine the effective gradient from the chainage and gradient. Okay, first of all, draw a table like this: chainage, gradient, rise, fall. Okay, rise and fall. Okay, chainage is listed and gradient corresponding gradient is listed. And to find the rise or fall, we have to just multiply the chainage with gradient. That is, here the chainage is 300 and gradient is 1%. So 300 into 1% means 1 by 100. So which is equal to 3 meters. Okay, so the rise and fall of different chainage are found. Then we have to draw a graph like this. Okay, on the x-axis we have to mark the chainage, and on the y-axis we have to mark the rise or fall. Okay, for 0 chainage, the value of rise or fall is 0, and for 300 it is rise is 3 meters, so mark 3. So for 900, the fall is minus 1.2 meters. Okay, so 3 minus 1.2, which is equal to 1.8. Okay, mark 1.8 here. Okay, then for 1500, there is a rise of 3 meters. Okay, 1.8 plus 3, which is equal to 4.8. And for 1800, there is a rise of 3 meters again. So 4.8 plus 3, which is equal to 7.8 meters. Okay. So here the maximum value is 7.8. We have to take the maximum value, and effective gradient is equal to highest value minus lowest value divided by corrected length. Okay, this one, corrected length, into 100. So 7.8 minus 0 divided by 1824.72 into 100, which is equal to 0.43%. And the correction is equal to that corrected length into 20%, that is 20 by 100 into effective gradient, that is 0.43, which is equal to 156.93 meters. So the corrected basic runway length is 1824.72 plus this correction, that is 156.93, is equal to 1981.63 meters.